In example 5, we need to sketch the parent function for the exponential. So the parent function here for the exponential, this is going to look something like this. And we're going to use 2 to the x power. You can really use any base you want, but if you use a base of like 5 or 6, then when x is 1, you're going to have, 2, you're going to have like 6 to the second power, which is 36. It's way off the graph. 1 would not work here. 1 to any power is 1, and so you just have a flat line here at 1, and that really wouldn't show you the shape of the graph. So usually we choose 2 here, keep the base small, and then the x is now in the exponent position, so that's why it's called an exponential. So we can do the same thing we did with the previous examples, and what we're going to do is we're going to graph some values of x and their corresponding outputs. So arbitrarily I'm just choosing these values in the domain. You can choose really any one of these, but some of them are going to be off the graph, like 2 to the 6th is a fairly large number, and so it's going to be the y value, or the f of x, the output, is going to be off the graph. So we'll try to stick right around 0 here. 2 to the 0 is 1, and so on and so forth. Well, let's actually figure that out here, and we'll see how it works. So 2 to the negative 2. Remember that when we have a negative exponent and a base, we can take that base, move it to the bottom, and the exponent becomes positive. So we got 1 over 2 squared, which is 1 over 4. 2 squared is 4. So the output here is a quarter. F at negative 1 is 2 to the negative 1, which is 1 over 2 to the first, which is just 1/2. We'll do f at 0 now. Anything to the 0 power is 1. Common student error here, and that's to try to multiply these two and get 0. It's not the case. An exponent is repeated multiplication, but it is not indicating multiplying the exponent and the base. You never multiply just the exponent and the base. Alright, we'll do f at 1 here. That's 2 to the first, which is just 2. Anything to the first power is itself. And then we've got f at 2, which is 2 squared. Notice how we're replacing the x, and that's 4. Negative 2 up a quarter is here. Negative 1 up a half is there. And we've got 0, 1, and we've got 1, 2, and then 2, 4. And you can see that this is not a straight line. Also, all the way on the left here, when x gets negative, then all we have is a larger denominator in the bottom, but we still have that 1 over. And so these points will just get very, very close to the x-axis. They won't actually cross it. So we would say that for this function there's an asymptote down here. And this horizontal asymptote, in this case the graph won't cross that asymptote. So I like to draw the right-hand side of the graph. You can draw whichever one you like. And we want it to be nice and curved, but still growing both up and to the right. This graph will continue very, very far to the right. And then I like to come over here on the left-hand side and get real close to the x-axis, but not cross it. You don't want to cross the x-axis here. The values down here are not possible for the graph. And that's a very actually important thing for you to understand.